Hello everyone, in this video we will see some useful tips for cracking DP-203 certification. I have used these tips to clear the certification, so I thought of sharing the tips with you all. In this video we're gonna cover these topics. First one is on Azure Data Factory, and second one is on storage, and third one is on Stream Analytics, fourth one is on Synapse Analytics, fifth one we cover the general other topics. Let's see a few tips on Azure Data Factory. Data Factory is a fully managed serverless data integration service. Is visually integrate data source with more than 90 built-in maintenance-free connectors at no added cost. You can easily construct ETL and ELT process in Azure Data Factory. The first step is on annotations. Annotations are additional or informative tags that you can add to specific data factory resources such as pipelines, datasets, link service, and triggers. By adding annotations, you can easily filter and search for specific data factory resources. In the screenshot here, I put the annotation for pipeline as well as for link service. So in the pipeline, you have something in the property section. You have something called annotations, and you can do plus and new. You can add in new annotations to that. For example, if I have ingestion pipeline, you can give annotation as ingestion. And if you have something called data transfer pipeline, then you can give the annotation as data transfer. Similarly, for any kind of pipeline, you can give specific word you can give in the annotations. So this annotation is going to help you during the monitoring of the pipelines. So during monitoring data factory, annotation helps you in grouping and filtering of the pipeline runs. So the next slide, I have this is the pipeline runs, so which gives you all the pipeline runs for the particular specific time frame. For example, if it is for last 24 hours, it will list you all the pipelines. So from that pipeline, if you want to filter certain pipelines, for example, the ingestion pipeline alone, you want to filter. How we can achieve is easily achieve through annotations. You can click on add filter. The add filter will give you list you the annotations. And click on annotations, it will give you a list of available values for the annotations. For example, if I have injection, I have a data transfer, those will be listed there, and you can choose those from the list. Based on your choose criteria, those pipelines are going to come up in your screen. So that's why this annotation is really helpful. During monitoring in data factory, annotation helps grouping and filtering of pipeline runs. Moving on to the next step. Next step is regarding the Azure given grid. For example, if you want to if a file is placed on a storage account and you want to trigger a pipeline based on that event, how we can achieve that? This can be achieved easily through the Azure Event Grid. For example, if I want to place a file in one of the storage bucket, or I want to delete a file, either or any events happening on the bucket or the folder like the storage account, whatever the activity is happening, either update or delete or add any of the things happening in the storage account, which when then I need to run the pipeline. So this can be easily achieved through Azure Event Grid. So when you place a file or anything in that storage account, this is going to capture in the Azure Event Grid, which in turn going to run the pipeline. So that's all about this step 2. Then go move to the next step regarding the pipeline run. For example, I have two pipelines here. The first pipeline is on lookup 1 and then followed by a get metadata activity. If the lookup 1 fails, then it's going to take the data from get metadata. So that is all about pipeline 1. Next about the pipeline 2. Pipeline 2 is going to execute the pipeline 1 and followed by a copy activity. So in this example, for example, when I'm going to run the pipeline 2 and if the lookup activity 1 in pipeline 1 fails, what's going to status of the pipeline 1 as well as pipeline 2 status? Because the pipeline 1, the lookup activities failed, then only we are going to run this metadata activity. So for the failures one, we have another activity which is going to run. So we are capturing the failure for the lookup 1 in the pipeline 1. So when you run the pipeline 2 and if the execution of pipeline lookup activity 1 fails in the pipeline 1, still we're going to mark this success for both the pipelines, pipeline 1 and pipeline 2. In simple, if there is a failure and if you capture that failure, then the pipeline is going to be marked as a success. That's all in short about this one. So this example is mainly to show if the pipeline 1 fails because in lookup activity, what is the status of pipeline 1 and pipeline 2. So in this case, both pipelines will show us success. Moving on to the next one. Next one is regarding conditional speed example in the data flow. The data flow, we have this, as we see in the screenshot, we're gonna split the incoming stream by year. We have the year less than 1960 and year greater than 1980. So that's how we're gonna split the incoming stream. So if you see the diagram, the split condition is mentioned here. Condition year less than 1960, year greater than 1980. and for all other years it has to go to the not be condition, use this output stream. So and you have continuous split on condition mentioned as first matching conditions. How this is going to represent in the code snippet? Let's see that. So this is how it's going to show up in the code snippet. It's going to clean data and split. Whatever split you have, those splits, all splits comes in that at the top. Year less than 1960 and year greater than 1980. So if you have three different domains, then all the domains will come on the top, and the next you will have the split by year. At there you have to define all uh, uh, the year logic. That movie before 1960, movie after 1980, and the default one. So at the end you will have a default one. So if the diagram, if you've seen the before UI, you will find the stream names here: movie before 1960, movie before 90, after 1980, and all other movies. So these stream names comes in this split by year at the last this code snippet. The default one also comes here, but the split condition will have only the conditions specific to that particular data stream. And this joint is called false because we have choose the first matching condition in this UI. So that's the reason you mentioned as that's the reason you find this disjoint equal to false in this code snippet. Moving on to the next tips. This is regarding SQL truncation error. For example, in the data flow, if you have a incoming data which is defined, for example, in this case, a varchar of 5, and if the incoming data is more than 5 characters, obviously the data flow gonna show SQL truncation error. How we can mitigate this one? So how we can do this? How we can resolve this issue is like we can use a conditional split here to to process the good data and the bad data. So how we can do is that we can choose split on first matching conditions, and you can, for the good rows, you can mention the condition here, length of less than or equal to 5, and the bad rows, the rest of the things which is not satisfying this condition goes to the bad rows, and the good rows, which obviously in turn goes into the database. The bad rows, we can add a sync to that, and which in turn can put that data into an storage account. And you can mention that in the output of the sync file, you can mention the file name here. So in this way you can capture the SQL truncation error, so by using conditional filtering method. Next tip is on trigger types in Azure Data Factory. In Azure Data Factory we have close to 4 trigger types. The first one is schedule trigger type, second one is tumbling window, third is storage events, and fourth custom events. That schedule trigger type, this is mainly based on a schedule. For example, if you want to run a pipeline every 1 hour or every 8 hours or every 5 hours, it's based on your time frame. If you want to run a pipeline, then you can use schedule trigger type. And if you next is tumbling window trigger type, this is when you want to process the streaming data at a certain intervals, then you can use tumbling window. Next one is storage events. This is based on any event that is happening on the storage account. For example, if the file is arrived in a particular storage account, then you want to run a pipeline, then you can use the storage events. It can be any events in the storage. It can be either arriving of file or deletion of file or updation of file in a particular storage. Then this based on that event, if you want to run a pipeline, then you can use the storage events. Custom events is kind of customizing your requirement based on that. If you want to run a pipeline, then you can do with the help of custom events. Moving on to the next one, we see how to create a trigger that runs a pipeline on a tumbling window. Tumbling window triggers are a type of trigger that fires at a periodic time interval from a specific start time while retaining the state. Tumbling windows are a series of fixed sizes, non-overlapping, and contiguous time intervals. For example, if you want to load the ADLS Gen 2 data into a database in Synapse Analytics, it need to include the late coming arriving data also, and it should run at a certain intervals. Then how we can configure in using tumbling window. That's what you could see in the screenshot. You'll choose the type as tumbling window. Then you need to mention start time when you want to start this particular trigger. This is, for example, I mentioned the data is 51922 here. Then this trigger this one should trigger after every 30 the recurrence I mentioned 30 and minutes here. So this should trigger every 30 minutes. In the advanced section, you can mention delay here. If you want to include the late arriving data, then you can mention the values here. Here is, if for example I mentioned here 2 minutes, so this is going to include the 2 minutes late arriving data also into the processing. This delay is like if you want to understand more about delay, this is what the definition of the delay. the amount of time to delay the start of a data processing for the window. The pipeline runner started after the expected execution time plus the amount of delay. So that's what, like if you mention 30 minutes, it's going to start after 30, start every 30 minutes, and it's going to wait another wait for 2 more minutes to get arrive. I mean, the process all the late coming data also. That's what mentioned here. The delay defines how long the trigger waits past the due time before triggering a new run. The delay does not alter the window start time. For example, value delay of 10 implies delay by 10 minutes. If you want to learn more about this particular example, you can go into this documentation and find more about this one. Another advantage of this tumbling trigger is, like in case of pipeline failures, the window trigger can retry the execution of the reference pipeline automatically using the same input parameters without the user intervention. This can be specified using the property retry policy in the trigger definition. So if you see the tumbling in the trigger option, there is something called advanced. If you go into the advanced option, you will find this retry option. So there you can provide the values, like how often you want to retry this particular trigger in case of any failures. So that's another advantage. So if in case of any failure, the tumbling window trigger can automatically re-trigger the pipelines. The next step is on integration runtime in Azure Data Factory. In Azure Data Factory, we have close to 3 integration runtimes. The first one is Azure, the next one is self-hosted, and the third is Azure SSIS. And if you see the screenshot here, Azure, like we have Azure and self-hosted integration runtime support both data movement as well as activity dispatch both in the private as well as public networks. But Azure has a SSIS mainly on the SSIS package execution on both public and private. Uh, Azure Integration Runtime supports connecting to data stores and compute services with public accessible endpoints, or by enabling the managed virtual network. Azure Integration Runtime can support connecting data stores using private linked service in the private network also. Azure IR is like comparatively the administrative effort is very low compared to using self-hosted, because self-hosted is mainly on the on-prem applications. So that's like advantage of using Azure IR compared to self-hosted. Self-hosted, like it like the management the administrative effort is very high compared to Azure IR. The next step is on continuous integration and delivery in Azure Data Factory. Suppose you have a change and you want to deploy the change into a higher environment, then how we can achieve it using Azure DevOps. So normally we'll make a change in a lower environment, and you once the change is completed and tested, you want to move the changes to higher environment, then you can use a release pipeline. With the help of release pipeline, you can move your changes from one environment to other environment. For example, in case you have dev environment, then you have a test, and then you have prod. So once you will do all testing, all your code changes and testing everything in a dev. Once the code is finalized, then you can use a release pipeline to push your code from dev to test and then test to prod. The next step is on source control Azure Data Factory. In Azure Data Factory, if you see here, when you configure in Azure configure using Azure DevOps, you could see the configuration as shown in the screenshot here. You will have a repository type, then you have the repository account, then you have the project name, then the repository name, followed by collaboration branch, then publish branch. And this publish branch is in your repository where the publishing related ARM templates are stored and updated. By default, it is ADF underscore publish. And the repository name, it's like your Azure repos code repository name. Azure Repos project contain Git repositories to manage your source code as your project grows. You can create your new repos or use an existing repos that are already in your project. Normally, the ARM templates will be available in this ADF publish. You can kept in by default. You can kept it in the ADF publish, or you can kept this under repository name / ADF. Then the name you can kept this ARM templates. If you want to know more about this source control in ADF, you can just go into this link. The next step is on parent pipeline. For example, if you have 4 pipelines, pipeline 1, 2, 3, and 4, the pipeline 1 is ingestion from source 1, and pipeline 2 is ingestion from source 2, and the third pipeline is data curation pipeline, and pipeline 4 is data modeling pipeline. And how this going to want to execute is like parent pipeline 1 and 2, they are independent of each other. and pipeline 3 that is dependent on completion of pipeline 1 and 2, and pipeline 4 is dependent on completion of pipeline 3. So if you have such scenarios, how we want to define the pipelines? To define this pipeline, what we can do is we can define a parent pipeline, and the in parent pipeline, how we want to do is like we want to run the pipeline 1 and 2 in parallel. Once both these completion successfully, then you want to trigger the pipeline 3, and once the pipeline 3 completed, then you can run the pipeline 4. So in that way, we can have this dependency setup for these 4 pipelines. The next step is on derived column transformation in mapping data flow. Use this derived column transformation to generate a new column in your data flow or to modify the existing fields. For example, when you have a source data that is loading into a container and you want to create another column called date time, how we can achieve this through derived columns. As shown in the screenshot, you can see the derived column settings. You could have the incoming stream as well as output stream name. And the columns, you can either modify the existing column, or if you want to add a new column also, you can use this column feature to add a new column in the output. The next step is on flatten transformation in mapping data flow. So for example, if you have a JSON file and you want to convert that into individual rows, we can achieve that using flatten transformation. So that's what I just showed in this here tip. So use the flatten transformation to take array values inside the hierarchical structure such as JSON and unroll into individual rows. This process is called denormalization. So this with the help of flatten transformation, we can flatten the JSON file into individual rows. Next, we'll see about few tips on Azure Data Lake Storage Gen 2. The first tip is on the file formats. Predominantly in the big data world, we mostly use Parquet and Avro file. There are different types of other file formats also. Predominantly we use Parquet and Avro. So the Parquet file format is mainly a columnar oriented data flow file format. Files are organized by columns rather than by rows, which saves storage space and speed up analytical queries. Efficient for reading a few set of columns from the tables. For example, if you have 50 columns and if you want to read only data from first 3 columns, so instead of storing that data as a different file format, we can store as a Parquet file format. So in that way it will be gonna easy to read the first few columns instead of reading the complete tables and fetching those 3 columns. Next, move on to Avro. Avro is a row oriented data file format. Avro stores the data definition in JSON format, makes it easy to read and interpret. The data itself is stored in binary format, making it compact and efficient. So basically, the Avro is a row-oriented data file format, and Parquet is a columnar data file format. Both support schema evolution, infer the schema. In general, if data is wide, has a large number of attributes, and is write heavy, then a row-based approach may be best. Here in this case, Avro is the best. If the data is narrower, has a few number of attributes, and is read heavy, then a column-based approach may be the best. In this case, Parquet is the best. The next tip is on file size. The first tip is like merge small files wherever possible, and it's good for batch processing. The next one is large files lead to better performance and reduce cost. Typically, the analytic engines have a per file overhead that involves tasks such as listing, checking access, and performance various metadata operations. So if you store your data as many small files, this can negatively affect the performance. In general, organize your data into larger sized files for better performance. Yes, so if you have many small files, you need to store the metadata, and that will gonna make an overhead for the analytical engines. So it's always better to have a big files compared to a small files. The next tip is on storage cost. Typically, we have 3 types of storage: hot tier, cool tier, and archive tier. Hot tier is kind of high availability, it's used for day-to-day activities, and the cool tier is kind of we can use the storage for infrequent access data, and the archive tier is like you can use the data which is not used for a long time, so we can keep that data in archive tiers. So if you see the availability, it's close to 99.9 for hot tier, and it's 99% for cool tier, and it's offline for archive tier. And if you see the usage cost, the hot tier costs very higher cost compared to cool tier. To cool tier and the archive tier are like kind of lower storage cost. And if you see retention period, for cool tier it's 30 days and the archive tier the retention period is 180 days. And if you see the latency, the hot tier the latency is milliseconds, and for cool tier also milliseconds, and the archive tier is hours. So in the latency, if you talk about latency, we can retrieve the data from the hot tier and the cold tier in milliseconds, but if you want to retrieve data from archive tier, it's going to take hours. Basically, what we need to understand from the storage cost is the cold storage, the data is accessed infrequently but must be available within 1 second. And for archive storage, data is not accessed for a long time, like we can use archive storage. That is kind of historical data or when old data which we don't want to access very frequent, we can keep that in archive storage. The next tip is on lifecycle management. This is helpful for data retention. The blob storage lifecycle management offers a rule-based policy that you can use to transition your data to the desired access tier when you specify the conditions are met. You can use the lifecycle management to expire data at the end of its life. Automatically delete the log at the end of each transition period. So the lifecycle management helps you to retain the policy. You can define like how long you want to keep the data. This will help you. The lifecycle management helps you to do that. The right hand side, you could find syntax of this one. For example, we have a syntax for tire to cool as well as tire to archive as well as delete. So you can see over this how we can move the data from one storage to other storage. Next one is storage policy example. For example, tire to cool value equal to 30, which implies that move the files to cold storage after 30 days. And also, the storage policy applies to the location mentioned in the rules. The next tip is on locally redundant storage LRS and the zone redundant storage ZRS. Locally redundant storage LRS copies your data synchronously 3 times within a single physical location in the primary region. LRS is the least expensive replication option but is not recommended for applications requiring high availability or durability. On the other hand side, zone redundant storage copies your data synchronously across 3 Azure availability zones in the primary region. For application requiring high availability, Microsoft recommends using ZRS in the primary region and also replicate to a secondary region. So if you see the diagram, the LRS, so in the primary region, we have data center. In the same data center, we have 3 copies. This is for LRS. But when you compare to ZRS, in the primary center, we have 3 data centers and 3 data centers each data center has their own copy. And so if you want to ensure the data lake remains available if a data center fails in a particular region. So in this case, if a data center fails, when you use LRS, the entire data will be non-available. But in case if you use ZRS, even if one data center goes down, still you can get the data from the other data centers. So in this option, ZRS is the best fit. So the zone redundant center would be the best fit as it copy data to 3 zones within the region. Next, compared to LRS, ZRS, we have something called ZRS and ZZRS, are like LRS and ZRS, but with the data centers in different Azure regions, but is more expensive than ZRS. ZRS preferred if the outage occurs in the entire primary regions. Next tip is on preferred way of storing data in Azure Data Lake Storage Gen 2. So for example, you can store data in this format. First the subject area, then the data source, then you can give the year, then the month, then the date, followed by file name, then you have the timestamp. Then if you store this data in this file format, then it will be easier to segregate the data for your processing. So first is subject area, followed by data source, then the year part, then month, then the day, then the file name. The next step is on analyzing the data in Azure Data Lake Storage Gen 2. For example, when the folder path is mentioned as csv slash busfare slash trip data underscore 2020 star dot csv, then in this case, Only the CSV file that have the file names beginning with trip data underscore 2020 will be considered for analysis. For example, if the same folder, if you have any other file with the similar name, but if the extension might be by Parquet or any other file format, that will only considered for processing. If something is mentioned as trip data under 2020 star dot csv, then only the CSV file that is the file name beginning with trip data 2020 will be considered for analysis. Next, we'll see a few tips on Azure Databricks. The first tip is on Azure Databricks clusters. Azure Databricks has two types of clusters. One is all-purpose cluster, other one is job clusters. All-purpose cluster we can call it as interactive cluster, and the job cluster we call it as automatic clusters. You use all-purpose cluster to analyze data collaboratively with interactive notebooks, and you use job cluster to run fast and robust automated jobs. All-purpose cluster can be shared by multiple users. These are typically used to run notebooks. All-purpose clusters remain active until you terminate them. Whereas job clusters is used to run a job, you create the job cluster when you create a job. Such clusters are terminated automatically after the job is completed. For example, if you want to run a job on a daily basis, then we can choose automated job cluster, because that's the best for jobs and automated batch processing, because that automated job going to create the cluster and terminates once the job got successful. Otherwise, if you don't use automated job and instead if you use interactive job, that job cluster going to run forever and it's going to cost. But in turn, this automated cluster will turn off once job is completed. So in that way, the cost, we can save the cost in this one. The next step is on how to reduce the cluster start time in Azure Databricks. For example, in Azure Databricks, if you want to start a cluster, the cluster gonna takes 1 to 2 minutes. Sometimes based on cluster size, it might take a little while as well. How we can reduce this cluster start time? So we can create a pool of clusters in the workspace that in turn can reduce this cluster start time. So that is what, if you want to reduce cluster start time, then use a cluster pool. The next step is on the streaming processing technology in Azure. So this the screenshot here gives you a list of streaming technology we can use in Azure. Either you can use for the streaming data, either you can use Azure Stream Analytics or HD Insight with Stream plus streaming, or Apache Spark in Azure Databricks, HD Insight with Storm, Azure Function, Azure App Service Web Logs. So one thing we note here is even Azure Databricks can be used for streaming. And if you see here, the supported languages are like Java, Python, R, and Scala. And if you see here in the integrated capabilities, you could see the event hubs, IoT hub, Kafka, HDFS, all those things you can use here. And also sync, you can use Azure Data Lake Storage. So just be aware that Azure Databricks can also process streaming data. And the language support here are Java, Python, R, and Scala. But if you see the Azure Stream Analytics, that does not support Java and Python. So predominantly if you want to use Java and Python, and then obviously we have to use Azure Databricks. But Stream Analytics does not support Java and Python. The next tip is on optimize the Azure Blob Storage file source with Azure Queue Storage. The Databricks ABS AQS connector uses Azure Queue Storage to provide an optimized file stores that let you find new files written to the Azure Blob Storage container without repeatedly listing all the files. This provides two major advantages. One is low latency and no need to list nested directory structure on ABS, which is slow and resource intensive. Next one is lower cost and no more costly list API request made to ABS. So for example, if you have streaming events and if you want to efficiently utilize this storage, we can use Azure Queue Storage. So this will provide low latency and low cost. Next step is an auto-scaling types in Databricks. Databricks offers two types of cluster node auto-scaling. One is standard, other one is optimized. Automated job clusters always uses optimized auto-scaling. The type of auto-scaling performed on all-purpose cluster depends upon the workspace configuration. The optimized auto-scaling is used by all-purpose clusters in the premium plan. Standard auto-scaling is used by all-purpose clusters on the standard plan. So in short, we have two type of clusters. One is autumn clusters, other one is all-purpose clusters, or we call it as interactive clusters. And we have two type of scalings. One is standard and other one is optimized. So this optimized is used in the premium plan for all-purpose cluster, and standard auto-scaling used for all-purpose in the standard plan. But the automated job cluster use always optimized auto-scalings. That's all in short about this auto-scalings. The next step is on cluster mode. Azure Databricks support three type of cluster modes: standard, high concurrency, and single node. The default cluster mode is standard. The cluster configuration includes an auto terminate settings whose default value depends upon the cluster mode. Standard and single node clusters terminate automatically after 120 minutes by default. High concurrency clusters do not terminate automatically by default. Let's see the definition of each cluster mode. Standard clusters. Standard clusters are recommended for a single user. Standard clusters can run workloads developed in any languages: Python, SQL, or in Scala. High concurrency clusters is a managed cloud resources. The key benefit of high concurrency clusters are that they provide fine-grained sharing for maximum resource utilization and minimum query latencies. High concurrency clusters can run workload developed in SQL, Python, and R. The performance and security of high concurrency clusters provided by running user code in a separate process, which is not possible in Scala. Single node clusters has no workers and runs Spark jobs on the driver node. In contrast, the standard cluster requires at least one work node in addition to the driver node to execute the Spark jobs. So if you see here, the standard clusters may recommend for a single user, but if you want a cluster, if you want to share with multiple persons, then highly you can use recommended one is high concurrency clusters. So this will be helpful for the maximum resource utilization as well as for minimum query latencies. The single node clusters that has no workers are just runs on Spark jobs on the driver node itself. But in contrast, the standard cluster uses at least one worker node in addition to the driver node. Moving on to the next step, what symbol should we use to switch between languages? For example, when you create a notebook in one language and if you want to switch to the other language, what symbol we can use? So you can use a percentage symbol and you give a language followed by the language. For example, if you are in Python notebook, if you want to convert that into a SQL notebook, then you can put percentage SQL. Similarly, if you want to convert to any other language, you can use the percentage symbol and put that as a language followed by percentage. The next step is on structured streaming. The, the outputs can be configured in three different modes. The first one is complete mode, the second one is append mode, and the third one is update mode. The complete mode, the entire updated result table is written to external storage. It is up to the storage connector to decide how to handle the writing of the entire table. The append mode, only new records appended in the result table since the last trigger were written to the external storage. This is applicable for the queries where the existing rows in the result table are not expected to change. In the update mode, only the records that were updated in the result set since the last trigger are returned to the external storage. This is different from complete mode in that update mode outputs only the rows that have changed since the last trigger. If the query does not contain aggregation, it is equivalent to append mode. Next step is how we can execute a Databricks notebook. We can use Azure Data Factory schedule trigger to execute a pipeline that executes an Azure Databricks notebook. For example, if you want to run a pipeline every day, then what we can do is we can use a schedule trigger which gonna run the pipeline, and the pipeline which in turn gonna execute a Azure Databricks notebook. So this way, from Azure Data Factory, you can use schedule trigger to trigger a pipeline, and then the pipeline gonna run the Databricks notebook. And next step is on when a library is not found when starting a cluster, where we can see the logs. So if the library is not found when you're starting a cluster, then we can check the cluster event logs, which tells you if there is any failure. The next step is how we can send Azure Databricks application logs to Azure Monitor. You can send application logs and metrics from Azure Databricks to Log Analytics workspace. It uses the Azure Databricks Monitor library, which is available on GitHub. So if you want to send the application logs from Azure Databricks to Log Analytics workspace, then we have to use Databricks monitoring library. The next step is how to retain interactive cluster configuration. Azure Databricks retain cluster configuration information for up to 200 all-purpose clusters terminated in the last 30 days and up to 30 job clusters recently terminated by the job scheduler. To keep an all-purpose cluster configuration even after it has been terminated for more than 30 days, the administrator can pin a cluster to the cluster list. So in short, if you want to keep the interactive cluster for a long time, then administrator should pin a cluster to the cluster list, because by default the all-purpose cluster are configured only up to 30 days. The next step is on how we can process the files from Azure Data Lake Storage account. In order to do this, first we need to mount the data lake storage in DBFS, then read the file to data frame, then do the transformation of the data frame, then store the output in a temporary folder, then finally write the result to a table in SQL DB or any other DB. Next, we will see a few tips on Azure Stream Analytics. The first tip on the definition. Azure Stream Analytics is a real-time analytics and complex event processing engine that is designed to analyze and process high volume of fast streaming data from multiple sources simultaneously. So mainly the Stream Analytics is used to process real-time processing of stream data from multiple sources. And also with built-in geospatial function, you can use Azure Stream Analytics to build application of or scenarios such as fleet management, ride sharing, connecting cars, and asset tracking. For the help of Stream Analytics, if you want to track a particular vehicle or particular asset, then you can use this geospatial function to do that. Mainly, if you see the streaming data, mainly the streaming data we can generate using IoT devices such as sensors, or you can use Kafka to generate uh, streaming data. The next tip is on query patterns in Azure Stream Analytics. For example, if you want to write a query to determine the time a user spent on a page or a feature, how we can write a query in Azure Stream Analytics. This is, for example, in the input we have a user, and the feature is the right menu, and the start event as well as the end event, and the corresponding time also mentioned here. You want to determine the time duration the user has spent on a particular feature. How we can do this with help of Azure Stream Analytics. That's a query we need to use to determine the time duration. We use a date diff column as well as the last function here. The date diff is a date specific function that compares and returns the time difference between two date time fields. The last function can be used to retrieve the last event within a specific condition. In this example, the condition is event of type start. Partition the search by partition by user and future. This way, every user and future are treated independently when searching for start event. The limit duration limits the search back in time to 1 hour between the end and start events. So that's a query. Mainly we need to use these two functions, the date diff as well as the last function, to determine the time duration for a particular user spent on a particular page or a feature. The next tip is on tumbling window. Tumbling windows are a series of fixed size, non-overlapping and contiguous time intervals. The following diagram illustrates a stream with a series of events and how they are mapped into 10-second tumbling windows. So basically here the tumbling windows are fixed size and they don't overlap with each other. And if you see in the diagram, it's like it's a 10-second tumbling window. So whatever the events comes in 10 seconds will not overlap with the next subsequent windows. For example, if you want to find the count of tweets per time zone every 10 seconds, then we can use tumbling window. Because in tumbling window, each tweet is counted only once. Because tumbling window is a non-overlapping and continuous time interval, the tweets won't overlap with each other. So if you want to count each tweet only once, then we have to use tumbling window. Next, we'll see the query syntax for tumbling window. So the same example, to find the count of tweets per time zone every 10 seconds, how we can write a query in tumbling window. So below diagram, the diagram shows here the syntax. So you could see here the select time zone, comma count star as count from Twitter stream, timestamp by created at, group by time zone, comma tumbling window, second comma 10. So this is the syntax to for tumbling window to find the count of tweets per time zone every 10 seconds. Basically, we need to use this timestamp by field. Then you have to use the tumbling window to identify the count of tweets per time zone every 10 seconds. Just remember this, we have to use this timestamp by as well as the tumbling window in this query. Moving on to the next step. The next step is on hopping window. Unlike tumbling windows, hopping windows model scheduled overlapping windows. Hopping window specification consists of three parameters: the timeout, window size, and hop size. Additionally, the offset may be used as an optional fourth parameter. Note that tumbling window is simply a hopping window which hop is equal to its size. The following illustration shows a stream with a series of events. Each box represents a hopping window and the events that are counted as part of the window, assuming the hope is 5 and size is 10. So if you see the diagram here, this is a hopping window example. If you see here, the events are overlapped. That's the reason we call it as a hopping window. For example, if you want to find for every 5 seconds, give me the count of tweets over the last 10 seconds, then we have to use this query to find out this. Basically, this hopping window, the hopping window is mainly to identify the running average. Or if, for example, if there's an overlapping window and if you want to find the running average, then you can use the hopping window. Just remember that if there's an overlapping window and if you want to find running average, then we need to use a hopping window. The next step is a real-time analytics dashboard for streaming data. For example, if you want to have a real-time dashboard, what are the components we should use in Azure for the input and for processing the data and what is the output? For the real-time streaming data from remote sources, we should use Azure Event Hub, and for the dashboard visualization streaming data, we should use Microsoft Power BI, and for streaming data processing, we should use Azure Stream Analytics. So these are the components majorly we use for real-time analytics dashboard. The input should be a Event Hub, and the output should be a Microsoft Power BI, and for the query aggregation, we can use Azure Stream Analytics. Next step is how we can optimize the performance for the Azure Stream Analytics. Scaling a stream analytics job takes advantage of partitions in the input and output. So having the partition for both the input and output, it's going to increase the performance. This is mainly for leveraging the query parallelism in Azure Stream Analytics. Partitions in input and output. Partitions let you divide data into subsets based on the partition key. If your input is a partition by key, it's highly recommended to specify this partition key when adding input to your stream analytics job. Scaling stream analytics job takes advantage of partitions in the input and output. Stream analytics job can consume and write different partitions in parallel, which increases the throughput. So basically, what you understand from this is if you want to optimize the performance, then use partitions in both input and output. The next step is use reference data for lookups in Azure Stream Analytics. Reference data is a finite data set that is static or slowly changing in nature. It is used to perform a lookup or to augment your data streams. Reference data is also known as a lookup table. Take an IoT scenario as an example. You could store metadata about sensors which don't change often in reference data. Then you could join it with the real-time IoT data streams. Azure Stream Analytics load reference data in memory to achieve low latency streaming processing. To make use of reference data in your Stream Analytics job, you generally use reference data join in your query. Basically, what we need to understand from here is reference data is a finite data set that don't change very often. We can use reference data as a lookup in Azure Stream Analytics, and you can use Azure Blob Storage or Azure SQL database to store this reference data, which can act as a lookup in Azure Stream Analytics. For streaming the data, you can use Event Hub, and for lookup, we can use Azure Blob Storage or Azure SQL database. To store the reference data, we should use either Azure Blob Storage or Azure SQL database, and for input streaming data, we should use Event Hub. The next tip is on lag in Azure Stream Analytics. The lag analytical operator allows one to look up a previous event in an event stream within a certain constraint. It is very useful for computing the rate of growth of a variable, detecting when a variable crosses a threshold, or when a condition starts or stops being true. For example, if you want to compute the rate of growth per sensor, then you can use a lag function to find this. This is the query here. The select sensor ID growth equal reading minus lag of reading over partition by sensor ID limit duration hover comma 1. So this query will find out the rate of growth per sensor. So you can use the lag function and the limit duration. You can use this with the help of this to we can identify the rate of growth per sensor in Azure Stream Analytics. Just remember the syntax, the lag function, the lag and also the limit durations. This will give you the rate of growth per sensor. The next step is how to improve the high availability of the real-time data processing solution. For that, we have to deploy identical Azure Stream Analytics job to pair regions in Azure. Basically, what we need to understand from here is for high availability of the real-time data processing solution, we should deploy identical Azure Stream Analytics jobs in paired regions. Just pause for a minute. You just read the slide by yourself. The next step is on watermark delay. This watermark delay indicates the delay of the streaming data processing job. There are a number of other resource constraints that can cause the streaming pipeline to slow down. The watermark delay metrics can rise due to the first one is not enough processing resources in Stream Analytics to handle the volume of input events. The next one is not enough throughput within the input event brokers, so they are throttled. Third one is the output sinks are not provisioned with enough capacity, so they are throttled. These are the three main reasons for the watermark metrics to rise. Basically, what we need to understand from here is the watermark delay indicates the delay of the streaming data processing job. Next, we will see a few tips on Azure Synapse Analytics. This Azure Synapse Analytics is a limitless analytics service that brings together data integration, enterprise data warehouse, and big data analytics. It gives you the freedom to query data on your terms using either serverless or dedicated options at scale. Azure Synapse brings these worlds together with a unified experience to ingest, explore, prepare, transform, and manage serve data for immediate BI and machine learning needs. The first tip on Azure Synapse Analytics is the create table syntax. So slide shows the create table syntax. Here, if you see the table options, we have the index here, the clustered column store index, clustered column store index order. Then you have the heap, then you have the clustered index. Then followed by you have the distribution. So you have three types of distributions. We have hash, round robin, replicate. When you define hash distribution, obviously we need to provide the partitions. Without the partition, with the hash will not work. Then we have the hash distribution as round robin, and also we have distribution as replicate. As we know, the hash is mainly for fact tables, and round robin is mainly for a staging table, and replicate is mainly for a dimension table. So when your distribution equal to hash, we need to provide the distribution column name. That is mandatory. For distribution equal to round robin index, if you keep it as heap, it's going to improve the performance. and the partition, we need to provide the partition column name. Just remember the syntax here. First you have the distribution followed by you have the partitions. Moving on to the next tip. The next tip is on round robin tables. A round robin table distributes table rows evenly across all distributions. The rows are distributed randomly. Loading data into round robin is fast, but queries can require more data movement than the other distribution methods. So round robin tables mainly, we know like it's mainly used for staging the data. It is like if you want to load the stage data very fast, then you can use round robin distribution. But when you query the data, then it's going to take more time compared to the other distribution because there are a lot of data movements need to happen for with help of round robin distribution. Then now we can see the hint on the round robin tables. So these tables can be used when you want to load data from Azure Blob Storage to a staging table. A heap table can be especially useful for loading the transient data, such as staging table, which is transformed into final table. And this is not recommended for very high volume of data. The next tip is on monitor transaction log rollback in Synapse Analytics. Monitor transaction log rollback. If your queries are failing or taking a long time to proceed, you can check and monitor if you have any transaction rolling back. We can check this information in sys.dm underscore pdw underscore nodes underscore tran underscore database underscore transaction. In this table, we can see if there is any transaction rolling back happened. The next tip is on query performance in Azure Synapse Analytics dedicated SQL pool. Materialized view and SLZ caching are used for query performance tuning in dedicated SQL pool. SLZ caching is used for getting high concurrency and fast response from repeated queries against static data. Materialized views allows data changes in the base table. Data in materialized views can be applied to a piece of a query. This support allows the same materialized view to be used by different queries that shares some computation for faster performance. The materialized views for dedicated SQL pool in Azure Synapse Analytics provide a low maintenance method for complex analytical queries to get faster performance without any query change. So these materialized views are mainly helpful if for complex analytical queries to get faster performance without any query change. Basically, what we need to understand from this is like with the help of material views, we can run a complex analytic queries to get a faster performance without any query change. Next step is the synchronized Apache Spark for Azure Synapse external table definition in serverless SQL pools. For example, how to ensure that tables are available automatically as an external table to the built-in serverless SQL pool for which table format we should use. Serverless SQL pool can automatically synchronize metadata from Apache Spark. Serverless SQL pool database will be created for each database existing serverless Apache Spark pools. For each Spark external table based on Parquet or CSV and located in Azure storage, an external table is created in the serverless SQL pool database. As such, you can shut down your Spark pools and still query the Spark external tables from the serverless SQL pools. So when you create the table using Parquet as a CSV file, so it's going to create the external table in a serverless SQL pool database. Then the next tip is on Azure Synapse Analytics statistics in Synapse SQL. So automatic creation of statistics is turned on for Parquet files. For CS file, you need to create the statistics manually until automatic creation of CSV file statistics is supported. Basically, what we need to understand from this is like automation creation of statistics is turned on for Parquet files, but for CS file, we need to manually create the statistics. The next step is on external tables in dedicated SQL pool and serverless SQL pool. You can create external tables in Synapse SQL pools via the following steps. The first one is create external data source to reference an external Azure storage and specify the credential that should be used to access the storage. Next one is create external file format to describe the format of CSV or Parquet files. Third one is create external table on top of the files placed on the data source with the same file format. So basically these are three steps we need to follow to create external tables in Synapse SQL pools. First one is create external data source. Next one is create external file format. Third one is create external table. The next step is how to identify data queue in table in Azure Synapse Analytics dedicated SQL pool. Data skew means data is not distributed evenly across the distributions. So how we can find the data skewness in Azure Synapse Analytics? So we can use sys.dm underscore pdw underscore nodes underscore db underscore partition underscore stats to analyze any skewness in the data. So data skewness means the data is not distributed across the distribution. And if you want to find the data skew, you can use sys.dm underscore pdw underscore nodes underscore db underscore partition underscore stats. Moving on to the next step. The next step is monitor resource utilization in Azure Synapse Analytics. The key metrics for troubleshooting the cache are cache hit percentage and cache used percentage. Select cache hit percentage, then use the addition add metrics button to add cache used percentage. So basically, when you want to monitor the resource utilization in Azure Synapse Analytics, use the cache hit percentage and cache used percentage. These two metrics will give you the resource utilization. Moving on to the next step. The next step is on Azure Synapse Analytics job. How we can view the status of a job. So we can view the status of a job from the monitor. From the monitor, select Apache Spark applications. The slide shows the screenshot of that one. So in the left hand side, you could see the Apache Spark application. Once you click that one, you will find the job details, and from that you can find status of the job. Moving on to the next step. The next step is on encryption at rest (TDE). TDE is nothing but transparent data encryption. This helps to protect against threat of malicious activity by encrypting and decrypting your data at rest. When you encrypt your database, associated backups and transaction logs are encrypted without requiring any change to your application. TDE encrypts the storage of an entire database by using a symmetric key called database encryption key. In SQL database, the database encryption key is protected by a built-in server certificate. The built-in server certificate is unique for each server. Microsoft automatically rotates this certificate at least every 90 days. The encryption algorithm used is AES-256. Here we need to understand like the encryption is addresses done using TDE, transparent data encryption. The algorithm we used here is AES-256. The next step is on resource classes in Azure Synapse Analytics. The performance capacity of a query is determined by users' resource classes. Resource classes are predetermined resource limits in Synapse SQL pool that governs compute resources and concurrency for query execution. Resource classes can help you configure resources for your queries by setting limits on the number of queries that can run concurrently and on the compute resources assigned to each query. There's a trade-off between memory and concurrency. Smaller resource classes reduce the maximum memory per query but increases concurrency. The larger resource classes increase the maximum memory per query but reduces concurrency. In short, what we need to understand from the tip is the larger resource classes increase the maximum memory per query but reduces concurrency. In short, if you want to increase the query performance, then you can use the larger resource classes which are going to increase the maximum memory per query. Now we'll see some tips from other topics. First one is find the duration of the activity in Azure Monitor. For example, if you want to find the activity which has take more time, how we can find that in Azure Monitor. So in the Azure Monitor, we have something called pipeline runs. Click on the pipeline runs, and if you go in the pipeline, certain pipeline, and you can click on the activity, and the activity will give you the duration, which tells you which activity has take more time. In short, if you want to find the duration of the activity, just go to Azure Monitor, click on the activity, and just find the time there. The next step is what are the Azure services that can be used to debug the activity. First one is ADF, Azure Data Factory, and the other one is Azure Databricks. With the help of these services, we can debug the activity. Next step is on continuous integration and continuous deployment. Steps involved in deploying this one, continuous integration, continuous deployment. The first one is create a repository and a main branch. Then create a future branch and make changes in that branch. Then third one is create a pull request. Fourth one is merge changes. Finally, publish the changes. So this is the flow in the CI/CD process. First one is create a repository and the main branch. Then create a future branch and make your changes in the in that branch. then create a pull request, then you do a merge changes, then finally publish the changes. The next step is on data transfer. And suppose you have a private network and does not support implement Azure Express Route or VPN between the on-prem network and the Azure. What are the options we should use? For this, if if there is no VPN connection, then we have to use the intelligent runtime as self-hosted intelligent runtime. We can use a schedule trigger, then copy activity you can use it for data transfer, and you should use a server level firewall IP rule to implement this one. The next tip is on column level security. This helps you to secure the sensitive informations. Azure SQL Data Warehouse now supports column level security, an additional capability for managing sensitive data in the cloud. You can use CLS to manage user access to specific columns in your tables in a simple manner without having to redesign your data warehouse. CLS eliminates the need to maintain access restriction logic away from the data in your other application or introduce a view for filtering out sensitive columns for a subset of users. So if you want to secure the sensitive information, you can use call level security. Otherwise, you need to create some views on top of this one to limit the access. But now we have call level security, which can secure the sensitive informations. Moving on to the next tip, how we can increase the throughput in an event hub. So this can be done with the help of partitions. So event hub throughput is scaled by using partitions and throughputs unit allocations. It's a best practice for publishers to remain unaware of the specifying partitions model chosen for an event hub and to only specify a partition key that is used to consistently assign related events to the same partitions. Event hub ensures that all events sharing a partition key values are stored together and delivered in order of arrival. If partition keys are used with publisher policies, then the identity of the publisher and the value of the partition key must match, otherwise an error occurs. So in short, if you want to increase the throughput of the event hub, just make it partitions. Let's use the partitions. And next step is on storage changing dimension called as SCD. The storage dimension table can help you to see the record from a given point in time. The different type of SCDs, type 0, type 1, type 2 and type 3. The type 2 SCD preserves the history of the data by adding new rows to as the existing data changes. So in short, if you want to see the point in time data, then you can use SCD type tables, and SCD type 2 table preserves the history because when there is a change, it will add a new entry instead of modifying the existing row. So that's all in short about SCDs. Moving on to the next step. The next step is on the query. So when you're running the query, make sure the column names mentioned in the query matches with the column name in the tables. Otherwise, the query throws an error message. So just make sure, like when you're running the query, the column names mentioned in the table and the column name in the query also matches. Otherwise, it throws an error. The next step is on the partition in the tables. The query performance will be increased if you have partition column in the table. For example, if you want to analyze the transaction data for every month, best option would be create a partition on the month. Otherwise, the query has to traverse through all the data. This partition will eliminate unwanted unnecessary reads. So to maximize the benefit of partition, by using a partition column in the var class, which eliminates the unwanted reads. Moving to next step. The next step is how quickly the data can be copied. First one is when there are small files, consider merging them. Next one is compress the files if possible. Then third one is column store index won't help you to load the table quickly for small tables. Next step is on data mart, star schema model, dimension versus fact table. The dimension tables contains attribute data that might change but usually change infrequently. Example, employee dimension table, the name and address won't change very often. The fact table contains quantitative measures data that are generated in the transactional system. For example, a retail business generates sales transaction every day. If you see a star schema, you will have the fact in the center and all the sides you have the dimension tables. Dimension tables are like the attributes which don't change very often, that we call it as dimension table, and the fact table we call it as the transaction data which holds all the quantitative measures, for example sales amount, all those information you'll find in the fact tables. The next step is the preferred way of creating a dimension fact table. The dimension tables. Dimension tables are mostly static and small, hence for distribution replicate is preferable. And for the fact tables are high volume tables, hence for distribution the hash distribution is preferable, because hash distribution you use a partition by field, so the partition which helps you to split the data and which will read the data very faster. And the round robin is not good for high volume data. Next tip is on fact table usage. Best practice is to use hash distributed for fact table, and the key should be a integer or big int, and the measure should be in the fact table. Example, total salary, sum of events, total time, and these measures should be in the fact table. Moving on to the next one. Next step is the creation of external table with the location. So when an external table is created using the location, the files under the main folder will be loaded in the table, and the files in the subfolder won't be loaded. For example, when you create an external table with the file path mentioned in the location, then only the files available in the main folder will be loaded, and files in the subfolder won't be loaded into the tables. The next step is on Azure Monitor. Data Factory stores pipeline run data for only 45 days. Use Azure Monitor if you want to keep the data for a longer time. If you want to keep the data factory metrics and pipeline run data, then you can use Azure Monitor, because after 45 days those will be expired in Azure Data Factory. So if you want to keep the Azure Data Factory metrics and pipeline run data for a longer period, more than 45 days, then use Azure Monitor. I will pause for a minute. Just go through the slide by yourself. The next step is on the last sync time property. For example, if you have a monitoring solution for a highly available Azure Data Lake storage solution that will include a geo-zone redundant storage is GZRS, then we should use a last sync time property. The last sync time property that indicates the last time that data from primary regions was returned successful to the secondary region. The last sync time property. Because geo-replication is asynchronous, it is possible that the data returned to the primary region has not yet been returned to the secondary region at the time of outage occurs. The last sync time property indicates the last time the data from the primary region was returned successfully to the secondary region. All writes made to the primary region before the last sync time are available to the read from the secondary location. Writes made to the primary region after the last sync time property may or may not be available for the read set. So for high availability solution, for a high availability monitoring solution, then we should use the last sync property, because this helps you. This will tells you like when the last replication was done to the secondary. Next step is on query performance. The hash distribution improves query performance on a large fact tables. Do not use a date column for a hash distribution, because all data for the same date lands into the same distribution. If several users are filtering on the same date, then only one of the 60 distribution do all the processing work. Do not use a date column, because when you use a date column, all the data pertaining to the particular date will go to into the same folder. So again, when multiple users reading to the same with the help of filtering to the same date, then everyone going to hit only one partition. They not use the other partitions. Better if you use other ID column, the data will be distributed across all the folders. The next tip is on backlog input events. Backlogged input events, the number of input events that are backlogged. Non-zero value for this matrix implies that your job isn't able to keep up the number of incoming events. If this value is slowly increasing or consistent non-zero, you should scale out your job. Adjust streaming units. So a non-zero value for this matrix implies that your job is not able to cope up with the incoming events. So in order to reduce the backlog input events count, we have to increase the streaming units for the job. So that's in short. To reduce the backlog event count, we need to increase the streaming units for the job. The next step is how we can manage the size of the transaction log file. So with help of sys database files, we can manage the size of the transaction log. For information about the current log size file, its maximum size, and the outgrow option for the file, you can also use the size, max size, and growth columns for that log file in sys database underscore files. You can get more information about this one in the link provided. Moving on to the next tip. The next tip is on multi-factor authentication and database level authentication. Azure Active Directory Azure AD authentication has the option to include multi-factor authentication (MFA). Azure AD authentication uses contained database users to authenticate identities at database level. Moving on to the next one. The next tip is on audit access to personally identifiable information. So for example, if you have PA data, how we can have audit access to that PA information. So we can achieve that using classification. By classifying as a sensitive classification, we can provide audit access to personal identifiable information. Data discovery and classification. It provides basic capability for discovering, classifying, labeling, and reporting the sensitive data in your databases. The most sensitive data might be includes business, financial, healthcare, or personal information. It can serve as an infrastructure for helping to meet standards for data privacy and requirements for regulatory compliances, and various security scenarios such as monitoring access to sensitive data. So by classifying this data, you can have audit access to the PA information. The next step is on partitions on Azure Event Hubs dedicated. The number of partitions is specified at the time of creating the Event Hub. It must be between 1 and the maximum partition count allowed for each pricing tier. We recommend that you choose at least as many partitions as you expect that are required during the peak load of your application for the particular Event Hub. You cannot change the partition count for an Event Hub after its creation, except for the Event Hub in a dedicated cluster and premium tier. So only for the Event Hub created in dedicated cluster and premium tier, we can change a partition after the creation of the Event Hub. The next tip on distribution. There are three types of distributions. One is replicated, next one is hash distributed, and the third one is round robin. A replicated table has a full copy of the table available on every compute node. Queries run faster on replicated tables since joins on replicated table do not require data movement. Replication requires extra storage though, and isn't practical for large tables. Predominantly, we use dimension table, and for dimension table we use the distribution is replicated. And the hash distributed table is designed to achieve high performance for queries on large tables. So predominantly we have hash distribution for fact tables. A round robin table distributes table rows evenly across all distributions. The rows are distributed randomly. Loading data into round-robin tables is fast. Keep in mind that queries can require more data movement than other distribution methods. Predominantly for fact tables, we use hash distributed, and for dimension table, we use replicated. Round-robin distribution is mainly used for tables which act as a staging layer, because there is no data movement. Just we need to load into staging table, and from there it has to go into on the next layer. For example, if you go into a QT layer, model layer, for that purpose, just a storage place. If you want to keep the data, then you can use round robin distribution, because we don't need to query the table or anything. Just need to store the data. Move on to the next step. The next step is on save data frame to a table syntax. So the syntax is like df dot write dot format dot partition by, then save as table. So in the format, you can use either delta, or you can use parquet, text, csv, or anything you can mention there. Partition by, you need to mention the partition column here. Then save as table, then you have to provide the table name there. The next step is on manage identity. Manage identity authentication is required when your storage account is attached to a VNet, virtual network. The next step is on call level security access using grantee SQL. You can implement call level security with the grantee SQL statement, and you can see the syntax in the slide. The next step is on row level security. You can implement the row level security by using the create security policy transact SQL statement. The next step is on SAS, how we can grant limited access to Azure storage resource using shared access signatures SAS. A shared access signature SAS provides secure delegated access to resources in your storage account. With a SAS, you have granular control over how a client can access your data. For example, what resource the client may access, what permission they have to those resources, how long the SAS is valid. So with the help of SAS, you can grant the limited access to Azure storage resources. Basically, what we need to understand from shared access signatures SAS is, with the help of SAS, we can grant limited access to Azure storage resources. The next step is on dynamic data masking, which helps to make to see only few letters from sensitive columns. Dynamic data masking limits sensitive data exposure by masking it to non-privileged users. Dynamic data masking helps prevent unauthorized access to sensitive data by enabling customers to designate how much of the sensitive data to reveal with the minimal impact on the application layer. So if you want to see only few letters from sensitive data, then you can use dynamic data masking. In short, if you want to see only few letters from sensitive data, then you can use dynamic data masking. The next step is on column store indexes. This helps for query performance. Column store indexes can achieve up to 100x better performance on analytics and data warehousing workloads, and up to 10x better data compression than traditional row store indexes. These recommendations help you queries achieve very fast query performance that column store indexes are designed to provide. Column store tables won't benefit a query unless the table has more than 60 million rows. Yes, the column store indexes is going to improve the query performance, but that's only for the very big table. And if it is for a small table, column store indexes will not helpful in the query performance. I hope these tips are helpful for your exam preparation. If you find it useful, please provide a comment in the comment section. Good luck for your exam. Thanks for watching.